displacement, and with the load, correct? In the x direction, sorry, the stress in x direction, I will also have a stress in the y direction together with the degree of freedom, your ux, your uy, correct? And I will have another one in the z direction, uc, sigma c, correct? Correct? I will have the stress in all three directions, correct? In a 3D solid. Makes sense, right? That is easy. Okay? So when it comes to a truss, the difference is that you will only have the stress in the longitudinal direction. That means each of these members, right, will only have a tensile or a compressive stress. Each of these members. It doesn't bend, okay? It doesn't bend, it doesn't twist, it only elongates. Can? So you do not need to worry about, just now when we talk about sigma x, sigma y, sigma z, you only need to worry about what is the elongation, what is the sigma f in each of these members. Do you know what I mean? Okay? So imagine if something like this displays, how is it going to displace? If I apply a load to this, right, it's only going to elongate. This is the example you have, right? Inside the learning guide, right? So when you have a load here, each of these members is only going to elongate. Okay? So for example, this member will be straight. Each of them either going to compress or elongate. That's all. Okay. Unlike just now when we say the beam, right? Let's say for a continuum beam, right? When you have a load, it will have a bending. Alright, you have a bending. You see a bending gradient here. But here no. You don't see any bending, you don't see twisting, you only see elongate or compress. Okay? So that's the difference in the truss. And we say that in the truss you only have one stress. So it's the longitudinal stress of each member. So that's the main difference in the truss. And the reason is because most of the time, right, why is it this case? Because most of the time, right, in the truss structure, the connection is actually a pin hinge. It's a pin hinge, whereby you will see that you allow it to rotate at the hinge. That's why that you don't carry forward any momentum. Okay? If you want to understand, you must let me know. Because I did just some background, then I will go into the actual part of this. So that's what we do the model. So the first part, right, we are going to draw is the first module in the final element one is to create a part which is essentially to create the geometry. Okay, so this time round we are only doing a 2D planar because in this case the truss is only a flat plate. If it only elongate or compress, right, then we will not have any elongation in normal direction because there's no external load in external direction, in and out of the direction. Okay, so you just be a y here, 2D developable. Okay, then we will draw. I'll finish this, then you all will try to catch up. Okay, you will draw the geometry. You can use anything to draw. There's no fixed rule how you're going to draw the geometry. Okay, in your assignment, likewise, there's no fixed rule how you do it. You just draw something. You don't need to be very accurate. You know, it's not like your cat. I'm not sure how many people have done cat before, but it's not like your cat. physically draw it in. For simple circle, you need that because there's a lot of help in the abacus to come to creating the geometry. So you see, the yellow line is the line you're going to draw. Then on the white part, there's a white line, right, which is what we call a constraint. So you see, once I draw a rectangular, right, it will tell me that the best way is to just draw something rough. After that, you go back to edit using the dimension, which I will explain now. So right now I have the rectangle, right? You can see that this line and this line, right, it will really assign it to have a right angle itself. Okay? So imagine if I was to change the geometry, let's say for example, I can change the geometry. Now this geometry, right, is 1.6, so I change it to 2 meter. Okay? And this is, let's say for example, this is 1 meter. So I can change the dimension of this doesn't matter. So now because I can't have it as a right angle, I will delete away the constraint. I'll delete away the constraint. Today is the first day you are doing today, so don't be stressed over it now. Why? You just need a little bit of practice on this. Then I wanted to make sure that this is horizontal. The top line, right, is always horizontal. Okay? Then I want the top line, right, if you see the geometry, right, you ask that first this top line to be 1 meter. Okay? And for the dimension and the edge, right, is all 1 meter each also. Okay? So we roughly have that trapezoidal geometry that I wanted to do. We need to create the diagonal truss, okay, in the middle for this truss, right? Diagonal brace for this truss. So I will bring it in. I will create a diagonal brace. Alright? Now this is important. If you see here, just now when I draw, right, this is only one member of the square, correct? So this is important because in abacus, right, when you do that, right, because this is a truss member. Imagine in the truss member, what does it mean? It means that I don't need to have any degree of freedom along the member itself because it's not bending. Imagine in the beam, you will need to have the degree of freedom. You need to have individual degree of freedom along the beam, right? In order for you to fulfill this gradient, you need to have a lot of nodes in the middle. Correct? Correct? Okay, but in the truss, what is the difference? I don't need, I just need, because this is straight, each of these lines is straight. Correct? So what do I need? I only need to know the displacement, the displacement at these two nodes. That was it. I only need to know the nodes at each end. Agree? Yes? So when it comes to this, abacus will only if the look here and look here because you draw it in one continuous member. So you need to break this member into two elements in order for you to generate the in order to tell the abacus that I wanted it to be a separate element.
Oh yeah.
I'll give you 5 minutes to try this. Like I said, when you start, I will remind you that you are going to go out first. Okay? Can you take 5 minutes to try?
How do you go for trade? This delete razor. How do I make angle? I also don't know.
angle cannot really attack.
The right angle cannot.
Kick right angle better. Constraint.
Cannot be. You must press enter instead. No, you click the constraint already and then press enter. The square, right? You click 4 square, then you press enter.
So some of you have this so you can expand. Okay, I forgot to say this. Remember we talked about it last 2 weeks back. This is called the model tree. You can either access everything through the model tree, through your menu bar, and to your the function bar here. So there's 3 ways you can do it: here, here, or here. Okay. I always like the model tree because it gives you exactly like how many what you have done. Sometimes because you don't then you create a lot of parts and then create a problem. Okay? So always like the model tree, if you can extend it, right, you can see that now the first part that we do, just like I created, I call the part trust. Right? I can expand it, and further expand it. After you have done your part already, you can expand here as well this. Then you can come back to the original sketch. This is called a sketch, which whereby you do the geometry, whereby you can access or you can edit your geometry just now. Just now somebody was asking, how do I delete geometry? So you just go to the eraser, correct, and just delete. Okay, the geometry. It doesn't matter because actually what happened in Abacus, right, is you trying to this is give you a constraint. Like this is giving you a constraint. Okay, if I draw a rectangle, you specify that I want it to be 2 meters by 1 meter, then Abacus will just find what is the best fit geometry to fit your different kind of constraint that you have applied here. Okay? Yep. Don't need angle, you just give it the dimension. You follow the learning guide. Can you follow the learning guide? Yeah. Do it one by one, then you'll find that actually it's actually very intuitive. Yep. So you see, those ones. So you have delete the constraint here. So now you go back and add the so look at this part. A little bit of flavor of how to use the learning guide, how to follow the instructions there. Then it will be easier for you to pick up this software. So if you place your cursor right over the button, right? If you place your cursor over the button, you see actually it comes up. Yeah. No, you need to find it. Yeah. It's okay. That's why I say there's no way around it. Unfortunately, I go through very quickly, then it actually doesn't benefit you. Yep. Yep, good. It's okay. So it's like say, this is not going to be fast. You're going to spend time on it. I just want to draw your attention to this one more time, which is actually very, very important. So you see here. Oh, okay. Hey, class. Before I forget, it's too long since I do this. I forgot one thing very important. Okay, which is the good thing. Okay, go to set. Every time, right? Go to set home directory. Okay, so don't save it at the template. Save it somewhere that you can access it. This is important because all the file will be saved here. Okay, so you go here. Remember we talked about this in Abacus, right? If it crash, it will come up with a journal file, JNL file. So you come up with a replay file, RPY file. Okay, if once you save it, it will be saved into something called a .jnl file. Both of these is in Python script. So you can use the Python, you can just change the extension back to Python and you run it in Python and it will be very fast. Have I shown you all the Python script yet? No, right? You can I can show you all before or not I didn't. Okay. So anyway, go back to here first. Let this be the temporary file. You see, can you see that? Set temporary directory here. Okay, save it. One more time, go to file, go to set work directory. Save it to the save it to a folder whereby so all the temporary file that is generated will be saved there. So you see now straight away you have the journal file because I save it. It's the first time you are doing it, so don't worry. It's not yours. Every year is not like that. Yeah, correct. I got not wrong. Normally in the last time you all can say the H or the K drive. H or K, right? Then you email back to yourself.
I'm not really sure
Okay. Hey, I do it one more time because I said this is something new to everybody. So let me do it one more time, and I will do it with the. Okay, so you see here, it says that in the part model, correct? In the part model, enter the part model, okay? Then in the part model, create a two-dimensional planar deformable using a linear mesh feature, okay? Hello. So we go here. Let me do this again. I will do this again. If I'm too slow, you let me know. If I'm too fast, let me know also. Okay, go back to a part model. Create a part model. So I call it a part truss. 2D deformable wire. This is a 2D frame. Just now remember I was saying this is 2D. We're doing the 2D space here. Okay. So what does it mean in the 2D space? I only have UX and UY. Alright, U1 or U2. Okay. So you see this is your X. This is your Cartesian coordinate. Your UX or your UY. The mesh, the grid size is just meant to help you to draw, so it's not actually very important. So we just key the figure because just now we are 2 by our dimension is 2 meter and 1 meter, correct? So it's about 4 meter. That sounds about right. So actually is also stated here. Okay, so you approximate size 4 meter, but this is not important. Okay, just let you compute. Okay, after that you come here. It asks you to draw a rectangular box, correct? Then this is what we will do. I go here. I draw a rectangular box. Just draw anything. It doesn't matter. The dimension doesn't matter. Okay. After that, we can come back and put it in the constraint. Then it asks you to you see the perpendicular constraint must be deleted. Alright. So I will come here. I will delete using what I will take the eraser. If you place your cursor over the button itself, you will see that. Okay, you can delete this. You press hold down shift so that you can select one and
I got one right angle.
okay, then delete. Can everybody up to here, okay? Can?
You need to specify the dimension.
You just press this one, then you oh, sorry. You see the window here, you say select the entities to delete. You must quick look at this. You see that? You see this? You see this? That's done. Okay? Then I want this to be horizontal, so I go and constraint horizontal. Okay? Then I'll add the dimension. You see here. I want to follow this so that you all can use this. Okay. Dimension to the left. Add the 1 meter. Then add dimension. You see, add dimension to the top and bottom so that they are horizontal and 1 meter, 2 meter. Okay. So you see here, there's a different button. This is all the constraint. So I can add the constraint here. Add constraint, okay? And I can add dimension here. The dimension is also another constraint. So I add the dimension here, alright? As 2 meter. So you see the window here, it prompts you new dimension. Now it's 1.275, so I add it as 2 meter. Okay? Then the top, I also want to add in the same constraint as I want to edit it, you see, I can go back here, edit dimension value. Okay? Why huh? Sorry? So will you all want me to just quickly go through or no, I think at the beginning we should still slow down like so that you now you see it zoom out already, right? You see that we have zoomed out. Okay, I'm not repeating this. You see that this is zoomed out already, you can't see the bottom member, right? So how are you going to zoom back in so you can see the view? This one is quite standard as your windows, so you can just go back Then just now we say, right, remember we say, and can't you see now this is one member on this one. Does it work? Why? Because remember we want this, we need to have to look at the figure to see how it elongates. So if it's one member, then this triangular, the diagonal breaks will not restrict on anything. Okay, so that's why we need to break this. Okay? Hey, you all seem to be very interested in trying on your own. If I do not let you all try it, you don't want that, or you want me to? Huh? Then, because you're not interested. So if you see, if I draw the line right, you see that in abacus, right? If I draw the number here, you see I draw the number. It will automatically align to the nearest, it will align along the line itself. So you don't need to worry whether it's touching or not. which is important because sometimes you will have this problem, okay? So you can see once I put it here, right, it will go into a solid, see, it touches to become a solid, means that it's at the midpoint. So abacus actually notates the vertices, like for example the middle of the member, end of the member. This one you need a little bit of try and error, then you will get it. If not, you always go to the end, you know, the other way you will always go to the end. So there's a few ways to do this, okay? There's a few ways, like I say, just like we say, we're going to break. We can use the auto trim to break this member into two members. If I don't want, I can also do the other way. I can just delete this member. I can just delete this whole member because now I have this point already, right? Then I just go back to point. I just go back to draw two lines. One line, then draw another line. Okay? Okay? Done? That's it. This is just the very beginning, each step, so I need to draw. Done. Okay, shall I go on? Huh? How long do you all need?
5 minutes, 5 minutes.
5 minutes, huh? Hey, we really don't have time, seriously. So you. Huh? It's correct. What this line? The yellow, good point, The green color line is the contrast, is the green line. We don't need the yellow line, right? Is action member. Hey, I want to point out, so you see that there's a lot of the just now the geometry, the function, right? You do not need to follow explicitly every time. Everybody can do it different way. You know, just now we're trying to show, right? You can do it different ways. It's fine. Sometimes, right? Sometimes your window somehow, right? But the eraser is being hidden. I couple of things also. Expand this more. I want to say this is important. I expand the model tree. Sometimes your geometry got problem. You want to go back and expand the model tree. Go back to the class. Just now I point it. You see that now my eraser is here, so you just need to pull down the window. Okay? I want you all to, hey, class, listen, I want you all to use the learning guide. Because this is going to be helpful for you to slowly it down. Rather than you look at the YouTube, it's going to waste more time. So you all must have the confidence with the learning guide first. Because, good point. Okay, you see, like I say, the different color scheme in abacus is important. Next class, I'm not going to answer the same question. If people have magenta color line, you better listen up. Okay? You see, the yellow color, just like we said, the blue color line is meant to be a green line, so it's not important. If that doesn't matter. Yellow color line is the actual member. White color line is the dimension line or the constraint. Okay? What happens if I over constrain it? You know, like you add too much constraint. Just for example, if I add too much constraint, what happens when it becomes the magenta color? When it, you will hear me say this many times. Different module, have different color schemes to avoid. Let's say in the part module, when you have a magenta color dimension line, that means that it's over constrained. That means you are over constraining it. Abacus must be free to generate different features. Remember just now when I haven't added in the 1 meter line, right, it doesn't go into trapezoidal shape. It goes to a few type of shape, right? Once I add in the 1 meter line, it straight away constrain it. It automatically generates this shape to fit in my provided constraint. If I over constrain this, I say 1 meter, 1 meter, 1 meter, then it doesn't allow Abacus to generate anything. Then it becomes a magenta line, and you cannot escape from this. You cannot generate a sketch. So what happens? You must go back and remove. That means you have over constrained this. You must remove some of the dimension line. Okay, or some of the constraint that I provided. So just go back to the delete, remove one of them, and you go back to my color. Okay, who else has this magenta color just now? So imagine if I have, imagine when I have, imagine I have over constrained. I'm not going to repeat that. Whoever asks from that line, the same thing, I'm not going to repeat that because now I'm saying that you all don't want to listen. Then don't ask me to repeat that. Okay? If I put in the dimension line, right? If I over constrain it, so it becomes magenta color, then you cannot generate that sketch. So you must delete that. So when you over constrain means that you have given too much parameters, so Abacus cannot automatically generate a sketch to fit all your criteria. Okay? So you delete one of them, you go back to the white color one. So as it's over constrained, you just start to delete some of the constraints that you think you have added latest. This is all an automatic algorithm. So sometimes you have this problem, sometimes it wouldn't, and the sequence also is important, you will realize that. Okay? This is not RMIT My Desktop. In RMIT My Desktop, you must save it under the H and K drive. You cannot save it on the desktop. You cannot save the K. You must do it on H and K drive. So you mean I have to open the H and Yep. You must press shift. Where's your No, that's why I say you all must you see what I mean. That's why you have confidence. You all need to try a few times, but there's no shortcut to this, I'm sorry. Try it on your own together with the guy. You get it better. It's like that. So,
还行啊。给我。真的是有钱。
You see, okay, let's go back to the sketch one more time. Just now you remember I make some edit to my sketch, correct? Okay, you have this yellow color tick here. Later I'm not going to repeat the same thing, I'm going to say it now one time. I have the yellow color tick, right? Means I have edit the sketch already. Okay? Let's say for example, if I edit the sketch now, let's do it again. Let's say for example, I edit the sketch. Okay? I want this, let's say for example, to be 0.5. I can, if I hold it here, right, you see, can edit dimension, I put it 0.5. Okay? Then, another thing is that just now somebody was asking a very good question. You will see a little black triangle here. Do you see a little black triangle here? That means that you can expand it. Press and hold the button. Then you see your break, your split lah, your trim lah, your auto trim. I do this I use the software quite often, so some of the things I forgot that must let people know because it's a very new software. I know for everybody. Sometimes it's very common to me and I didn't remember that must let you know. I said that's why I'm trying to go through. I'm trying to slow down here to let everybody get more confident with this. Okay, done Okay, so you see I updated it already, right? So I done. Then you will see that, how come the dimension is not updated? Okay, because if you expand it, you see that there's a yellow tick here, and if you read, you must read all the windows one. Okay, you must read the window here, you must read the window here. Okay, say the feature has not been generated. Okay, so you must regenerate this sketch. Okay, you press OK. Then you see that this when there's a yellow color tick means that you need to regenerate this. Okay, then you go to here. You double click on this yellow color tick, they say regenerate, you say OK. Okay? Can? Don't worry, at the end, every year, the first lesson on this, everybody is very stressed. At the end of the 6th lesson, everybody is expert at this already. So it happens every year. Okay, I do it again. So I turn it back to 1. Done. Okay, now you see there's a yellow color tick here already. Okay, so I must right click this. I just double click this. And regenerate. Okay. Okay. Are we done with the geometry? We must move on already. Okay, I'll go on. You see, after we have done the part, right, which is the geometry, what's the next thing we need to do? We need to do the property. Okay? Go to property. If you go back to your learning guide, right? Okay, go back to the learning guide. You see the learning guide. It says create material. Okay, so double click on the material, edit the material, call the material steel. The name, everything that is in italic is not important, so you can call it whatever, material 1, material underscore 1, it doesn't matter. I wanted to stress, and I'm not going to repeat this, importantly, don't have a space. Every time when it comes to your naming or whenever you name anything in Abstract, don't have a space there. Okay, always have an underscore or a dash or whatever. Don't try not to have a space. Sometimes it creates problem. Okay, so you see here for the material, we're using mechanical elasticity in the menu item. Okay, so I'm going to go here. Under here, right, it says create material. You look at the thing, it says create material, elastic. Remember just now we said mechanical, elastic, alright? Then elastic. Alright. So you see here, it says select the elastic property, then enter in the value. This, I ask, so this model, right, what is the dimension for this model? Are we choosing, just now remember we talked about this, whether is it in meter or is it in millimeter? Meter, correct? So what is your stress? Because your force is always in Newton, correct? So this force, the stress here, is it in megapascal or in Pascal? Pascal, because it's Newton per meter square, correct? So imagine your steel material is what? Your steel material is 200 gigapascal. Alright. So what must you enter inside here? Because like I said, if you look at this, everybody will ask you to enter in what is your Young modulus. Is there a unit there? No, there's no unit. So what are you supposed to enter here? 200. 200 what?
E to power 9.
Yeah, so it's supposed to 200 E9 Pascal. Okay? If it's in millimeter, what must you enter? It will be 200 E3 megapascal. Okay? So, but in this case, it's in Newton per meter. The megapascal one, don't worry. When we go to that, I will go back. I will stress that again. Okay, so don't worry. Okay? So it's 200 E9.
Wait, how you go?
Follow the guy. Okay? Here. Huh? Then what? Just that.
Con học là đẹp rồi, sẽ còn học.
No.
Rồi bài thi mà. Bài thi mình
Property, then create property. Okay, so can we create the steel property? Here, go to create property.
We still have to select the wire.
Yep. You can also do it from the material tree here. You can also do it from the model tree, right? I can also right click, create. Like I said, you can do it in 3 ways. Or you can also do it here, create. All is the same. Can?
But it doesn't do anything. Oh, okay.
Can? That's why need a little bit of. That's why it's just some point as I create the geometry. If you go, you know, just now when we do the trapezoidal, right? You know when you do the trapezoidal, if you jump something like this, right? When I do this, I just now when we do this, sometimes it cannot be like this first, okay? Correct? So the sequence is important. Sometimes, so it's like, if let's say for example, if you do it as 1 here, correct? And you have this is like horizontal, what happens is it could just collapse this whole thing. Then it becomes a overlapping line like this. It could be, right? Okay? So that's why you just need to switch the sequence around. Do this line first, and do this line, assign it to be 1 first. Try to use a different sequence, it's okay one. Okay? Or if not, you give it an angle. Just have or just give it an angle 60 degrees. Let's say give it some degree for 60 degrees, let's say. Okay? After that, come back and delete it 60 degrees. Okay? So whatever you have appear on the screen is the constraint. Okay? So this, how you implement it doesn't matter. Sometimes the sequence you manipulate, you will give every time by This is important. Hey, class. Listen here. Let's say for example I delete this, okay? Oh no. I know what's the problem. There was no point to say this now. You have something like this, class. See, you have something like this. Okay. Then I wanted to. Then you see I have the, you see that I have the cross. I cannot exit from here, correct? It's because you have chosen an extrusion instead of wire, chosen an extrusion. So what does extrusion mean? I must remember when we do the continuity, I must have a closed section so that I can extrude a closed section. You have chosen the wrong one, you have chosen the extrusion instead of the wire. That's why I said that is the most important part just now. The first part is the most important part because you don't want to spend your time drawing the sketch and you realize that this is totally wrong, you know. When you choose the part, right, create the part, it must be a wire. This is the most important part. Your 3D, 2D is all the important. I say this up front. So if your model doesn't work because of this, don't waste your effort. Okay, this is the most important part.
Backup go.
Why? Can? Okay, we will take a 15 minutes break.
Okay lah,
We'll take a 15 minutes break. If we come back at 3:45. Okay? If you all want to continue, you all can continue to work it down based on the learning guide. Later I will just go through quickly. I will finish up the model and I want to show you the post-processing part. Okay?
Dia awak fikir apa? Ibu ada cakap apa? Jadi